All right, class, we're going to finish our discussion on section 3.1 where we're solving linear equations. We're going to solve linear equations now that are in non-standard form. All right, so to solve linear equations that are in non-standard form, we need to first be able to identify what is standard form. So standard form is what we've been doing so far, where you have ax plus b equals 0. Okay, that's standard form. Non-standard form is going to be literally anything else. So if your equation is written in a way that is not exactly like this, you know you're dealing with an equation that's in non-standard form. So how do you solve equations that are in non-standard form? Well, the official way to solve them is to first combine like terms or to simplify until it is in standard form. And then once it's in standard form, you will follow the rules of algebra that I laid out before, where you isolate the variable and whatever you do to one side, you do to the other to solve for the variable, okay? But basically, to solve equations that are in non-standard form, you're just really going to follow the rules of algebra. You're going to do the same exact thing that you were doing before, except now you're dealing with something that may be like a little bit more complicated, okay? Don't worry about the forms that you're dealing with. Don't worry about getting it to a certain form just yet. Just literally just try to solve using the rules of algebra, the rules that I told you before, okay? So let's go ahead and let's solve one. If we have 3y plus 8 minus 5y equals 4. First thing we want to notice is that our variable is now y. We've been dealing with variables of x, but it really doesn't change anything at all, okay? We're still dealing with a variable that we're trying to isolate. And then once we try to isolate that variable, the way we're going to do that is by doing whatever we do to one side, we're going to do that to the other side as well. Okay, so let's go ahead and let's try to solve this. If we have 3y plus 8 minus 5y equals 4, we're going to deal with it the same way that I told you before. We're going to work from the outside in. So we're going to take away the thing that is farthest from the variable. Here, 3 is attached to the y. Here, negative 5 is attached to the y. The only thing that's far away from the variable in this case is plus 8. To be able to take that plus 8 away, we're going to have to subtract 8. Now remember, whatever we do to one side, we do to the other. But here we have a pretty long equation. So how do we know what the side is? Remember that the side just means the equal sign. Okay, we're on the western hemisphere here. We're going to subtract 8 from this side, which means we're going to subtract 8 from this side. And then we're going to end up with the equation 3y minus 5y equals negative 4. All right, so now that we have this, it's pretty easy to see what we have to do next. If the official way of how to solve is to combine like terms, we're going to combine these two terms. 3y minus 5y is going to give you negative 2y. We didn't do anything to move anything or to cancel anything out. All we did was combine like terms. So in this case, we're not subtracting 5y from this side, okay? When you're combining like terms, you just stick to the one side, and it's just the only thing that changed here was that we combined these two like terms, okay? We didn't move anything from one side to the other, or we didn't cancel anything out, all right? So here you have negative 2y now equals negative 4. Now you do have to do something else here to be able to get that y by itself, and that's going to be to divide by negative 2. Once you do that, whatever you do to one side, you have to do to the other. So y is going to equal negative 4 divided by negative 2, which is going to equal 2. And that's your final answer. Now, one thing we didn't do in the previous section that we have to start doing now is to check our answers. How do we check our answers? It's really simple. What you have to do is you take the answer that you got, and let's make sure that this answer actually works. One, let's make sure that we didn't make a mistake while we were solving. Or let's make sure that this is actually the answer to this question, because sometimes you may solve but then get an answer that actually doesn't work, okay? An incorrect answer just because of how the equation is set up. So let's go ahead and let's figure this out. The way that you do it is that you take your value that you found and you just substitute it in to all of the variables in the original equation. So let's go ahead and let's rewrite this. If the equation was 3y, we're going to write 3 times y. If y equals 2, it's going to be 3 times 2 plus 8 minus 5 times 2 equals 4. Okay? And now that we have that, we can go ahead and solve. So let's go ahead and solve. This here is basically an equation where we just go ahead and we just combine like terms. We just simplify it, okay? 3 times 2 is going to be 6 plus 8 minus 5 times 2, which is 10. Now, why don't we subtract 8 minus 5? Well, we're using PEMDAS, okay? We always use PEMDAS. And PEMDAS tells us to multiply first. So we're multiplying this first, and then we're multiplying this first. We're writing it all out. And now what we want to check is that the left side equals the right side. So we have 6 plus 8, that's going to be 14, minus 10 equals 4. 14 minus 10 is going to equal 4. If 4 equals 4, if your left side equals your right side, then you're good to go. That's your final answer, okay? So make sure that from now on, at least in the beginning, you're checking your answers, okay? Once we start dealing with quadratics or with other types of equations, it's going to be pretty much mandatory to check your answers. But for now, still make sure that you're checking your answers until you get the hang of it with the linear equations. Let's go ahead and let's solve example 6, okay? So example 6 is a little bit different. Why? Because here you see that we actually are going to be using the distributive property. So to be able to solve this, we're going to follow our rules. And our rules are basically to isolate the variable, and to whatever we do to one side, we're going to do to the other, okay? But here I wrote a tip. Here you see that you have a variable on one side, and you have another variable on the other side. Let's go ahead and let's try to reduce the number of variables before we actually isolate the variable. What's going to end up happening if we try to isolate a variable on one side and try to isolate the variable on the other side? It could be a little bit confusing. Let's try to combine the variables from both sides, combine them into one variable, so then we can solve that, okay? So the first thing we want to do is try to get the variable by itself on each side and then combine them. So move the variable to the other side so we can combine it from one side to the other. Okay, so the first thing we're going to do here, we see that this x minus 3 is attached to this 2. Let's just try to use the distributive property first. So we're going to do 2 times x and then 2 times negative 3. All right, and if we do that, we still have x plus 6 over here. We haven't done anything to this side. 2 times x is going to be 2x minus 3. 2 times 3 is going to be minus 6, okay? Now, here we have a variable over here and a variable over here. Reduce the number of variables. What does that mean? We want, instead of having 2 variables, one on each side, let's just try to get one variable, okay? One variable by itself. The best way to do that would be to move the variable from one side to the other. I like to keep the variable or the value of the variable positive as much as possible. So I'm going to go ahead and move this x over here, and I'll show you what I mean. If I subtract x from here, that cancels out. Whatever I do to one side, I do to the other. And now 2x minus x is going to equal just 1x. If I would have taken this 2x and subtracted 2x from here, I would have done minus 2x and then x minus 2x. So then I would have gotten a negative x value on the left side. I like to keep the variable positive. It doesn't matter which way you do it, you will get the same answer. Okay, so let's rewrite what we have here. All right, so now I have x minus 6 on this side. I have 6 on this side. To be able to get that x by itself, I have to add 6 to both sides. So if I add 6 here, I add 6 here, and now I have 12 equals 1x. 1x just means x, so our final answer is that x equals 12. If we're going to go ahead and solve this, we're going to plug in this x equals 12 into both variables. And if we go ahead and we do that, we check it, we will see that the left side will equal the right side, and then the answer will be correct, but you can go ahead and check it on your own time. Lastly, this is the last problem. What we're going to do is we're going to try to solve these two equations, and we're going to try to solve them separately. So go ahead, pause the video, solve each one of the equations, tell me what the answer is going to be. These are a little bit different, so don't be like too scared if you get a weird answer. So pause the video but right now, and then in about 1 second, I'm going to start again. Okay, so we're going to go ahead and start with this equation right here. We have 2x plus 3 equals 2 times x plus 4. Like I said, we want to reduce the number of variables that we have, so we're going to use the distributive property. Okay, we're going to do this here and this here, which means we're going to end up with 2x plus 3 equals 2x plus 8. Okay, all I did was multiply that 2 into both of those values. Go ahead and get that variable by itself. So combine, reduce the number of variables, subtract. Since this one's 2 and this one's 2, we're just going to subtract 2x from both sides. And then what do we end up with? 2x minus 2x is going to equal 0x. That cancels out. This one's going to cancel out. We still have 0x plus 3 equals 8. I like to keep that 0x there so that you remember what was attached to the variable. Even if you have a 0 at the end, you could just simplify it. But let's go ahead and let's keep it as 0x for now until we get our final answer. And then we go ahead and we subtract 3 from both sides. So now we have that 0x equals 5. 0x is just going to equal 0. 0 equals 5. We know that's not correct, okay? A 0 cannot equal a 5 because they are both constants, okay? A 0 is always going to be 0. 5 is always going to be 5. So this does not work. The way that this equation was written does not solve for x, okay? Everything cancels out. This equation is incorrect, all right? So you don't have an answer to the x in this equation. Basically, if you see the way that we wrote it right here, it's saying that 2x plus 3 is going to equal 2x plus 8. Right off the bat, you know that that's not going to be true. Because if x has to be the same thing, whatever you plug in for x, this side cannot equal this side. So the left does not equal the right. Okay, this equation is wrong. It's a bad equation. Okay, there's no way that the left can equal the right side. There's no way that you can get an answer for your x. Okay, we're going to move on to this equation written a little bit differently as well. We're going to do the same exact thing. Okay, so 4 times x, 4 times 3, we're going to get 4x plus 12 equals, and if you see right off the bat here, you can tell that left side is equal to the right side. Okay, so these types of equations are a little bit different in the way that they're written. They're just the same equation on the left side as they are on the right side. Okay, in this case, it was not the same equation on the left side that it was on the right side. Here, if we try to solve this out, we're just going to get that 0 equals 0, or that a value equals the same value. But let's go ahead and let's solve it.